Hi, this is a Rosie math teacher coming at you from my 7th period accelerated grade 7 math class. I didn't get enough time earlier to thoroughly explain number 12 on tonight's homework for lesson 1-9 textbook 78. And yes, you have to finish your homework on the weekend. Let's go to item number 12. It says, the table shows the approximate population and land area for several states. Which state has the least population density? So when you're discovering what the density of the population is, they're asking you to tell them how many people per, a fraction bar always means per square mile. Class, please write that as a representation of the ratio that will help you find the answers you need on tonight's homework number 12. People per square mile. So for example, for the state of Arizona, the population, or the number of people expressed in scientific notation form, is 6.83 times 10 to the 6. So when you are computing that later, you are going to write that as your people number. So 6.883 times 10 to the 6th power. That becomes your numerator. Then for your denominator, you are going to write the land area in miles squared, so that's square miles. In this case, 113,594. Let me recopy that here, 113,594. You could either write it as a fraction and find the decimal value, or you could literally type into your calculator 6.83 times 10 to the 6th power divided by 113,594. Obviously, don't put a comma in your calculator. Once you have divided that, you will get an answer value. When you get that answer value, please write it here in your textbook so that you can see what that number was worth. And class, what that number means is there is that average number of people per a single square mile in the state of Arizona. So once you write that number down, it might even help your brain to take that number and round it to the nearest whole human being, and that's the approximate number of humans per square mile in Arizona. You would then do the same thing with your Colorado information. Again, what is the number of the population going to become? If we talk about it like a fraction, it is the what of that fraction? It is the numerator of that fraction. And then your land area miles squared is the what of that fraction? Denominator. Or you could write yourself a division sign in between each and every one of these pairs of numbers. And then the answer that you get will always be written at the end. Now, if they say they want the least density population, which state has the least density population? Are you looking for the number over here that is the greatest, or are you looking for the number that is the lowest? You're looking for the number that is the lowest. And then that would be your answer for which state. Simply follow whichever number is the lowest, follow it over to the left until you find out which state it lines up with, and then that state is your answer. Are you understanding what you need to do? What is your question, sir?
Do we do the same thing for question 11?
I'm about to talk about number 11.
Okay.
Okay, and I see my class is very busy starting to work on number 12. Can we take a moment's break from that, guys, so I can explain to you number 11? I'm working my way backward in case anybody still needs a review from number 11 that I did on a video earlier today, but I want to do it one more time on this video because these two items are probably the hardest out of all the homework. Number 11, everybody looking at number 11 with me now. Give your brain a break from number 12 and go to number 11. The table shows the approximate number of insects in each group. What is the combined population of the 4 insect groups? Class, look at the chart to the right. We're talking about honeybees, ants, termites, aphids. Each amount is times 10. The first is to the 4th, and then times 10 to the 3rd, times 10 to the 5th, times 10 to the 4th. Guys, do you notice that each of these exponents are pretty close to the others, right? So pick one that is kind of the middle ground. Which exponent would you say is kind of in the middle? The 3, the 4, or the 5? The 4th power. So go ahead, I'm going to draw a box, a red box, around my amounts that are to the 4th power because I'm not going to change those at all. I'm going to keep those as they are. I can't emphasize enough, class, and everybody out there, listen really closely to these steps because this is a trick that will help you with a lot of the type of questions they will ask you on the review on Monday and on the real test on Tuesday. Guys, you have a pre-test on Monday and the real test on this unit on Tuesday. So make sure you are understanding how to do this. When you want all of your exponents to be the same, you want that because then instead of having to find the standard form, find the standard form, find the standard form, find the standard form, and add these really big numbers, you can just make all of your exponents the same value so that you tweak just the number coming before that, and then all you have to do is find the sum of all the new numbers that you will get in this section. So stick with me as I explain what you do. I need eyes looking up here so that I know everybody is learning this method. It's a little more than what you might anticipate, so I don't want you thinking I don't need this. You all need this. Even my brilliant mathematicians who sit in the second row. 2 boys in the second row. You're brilliant mathematicians, but I still want you looking up here. Are you watching? Okay, here we go. When we've already agreed we want to change them all to 10 to the 4th, correct? Yes. So I'm going to go to 10 to the 3rd, and I have to what by 1 power to turn that into a 4th? Do I add a power or subtract a power? Add a power. So I'm going to increase by 1 power when I turn that into the 4th power. If I am increasing this factor by 1 power of 10, I must decrease this factor by 1 power of 10 so it stays the same value. Guys, do you get how if you increase one factor by a power of 10, decrease your other factor by a power of 10, you're keeping the same value? That is how math works. So on the number 6.822, I will scoop that decimal 1 time, what direction? Okay, remember I increased this by 1 power of 10, so I must decrease this by 1 power of 10. Which direction will I move that decimal?
Right.
To the, okay, am I doing something wrong? Okay, so that was to the power of 3. We are increasing it to the power of 4 over here. If I am multiplying 6.822 times 10 to the 3rd power, won't I get a lower value than if I multiply 6.822 times 10 to the 4th power? Yes. I want to get the same total. So that is why, using the rules of math, if I multiply one factor by a single power of 10, I must reduce the other factor by a single power of 10. So while this gets multiplied by 1 more 10, this gets divided by 1 more 10, meaning that decimal scoops 1 time to the
Left.
Beautifully done that time. So scoop your decimal over here, X out the original decimal, leaving you with 0.6822. Are you understanding now?
Yes.
So now let's do the same thought process, but with the item we have not yet changed. It says 9.8 times 10 to the 5th. I want them all to be times 10 to the 4th. So if I change the power of 5 to the 4th power, have I gone down a power or up a power? Down. So if I go down a power on this factor, I have to go up 1 power on this factor. So I'm going to scoop that decimal which direction?
To the right.
To the right. How many times? Beautiful. So this amount becomes what number, class?
98.
98. Beautifully done. Now that I have all of these times 10 to the 4th, all I have to do is add up all of my numbers that are inside my purple circle. When I get their sum total, I will write that number on my paper, and then I will say times 10 to the what value, class?
4.
Keep it times 10 to the 4. All right, I really feel like this will help my students do very, very well on those last two very most challenging problems from today's lesson. I wish you well, and I hope this helps.